Hi to all. Today's topic is law of conservation of energy in LC circuit. In LC oscillations, then law of conservation of energy is there. That we are going to discuss the law of conservation of energy in LC oscillations. Show that or otherwise, law of conservation of energy means in the LC circuit we have a capacitor and inductor. Capacitor is initially it is fully charged and then connected to the inductor. Initially the capacitor has the maximum energy and inductor has the minimum energy. After some time the energy exchange between the capacitor and inductor, because the capacitor starts to discharge, that's why the energy stored in the capacitor decreases, energy stored in the inductor will be increases. But the sum of energy stored in the capacitor and inductor is remains constant and it is independent of time, that we have to show. It is very important. Now let us see here, a capacitor fully charged and connected to inductor. This is a capacitor, it is fully charged, its initial charge is Q0 and it is connected to inductor of inductance L. And Q0 be the charge on capacitor at a time t equals 0, means starting charge. Starting the capacitor has the maximum charge, that is the Q0. Q is the charge at any instant of time t, at any instant of time t. What happens at here, the charge will be decreases in the capacitor because the capacitor starts discharge, that's why the charge decreases. At any instant the charge we can consider as t. And the capacitor, C is the capacitance of the capacitor, L is the inductance of inductor. Inductor means, okay, a solenoid, any coil with large self-inductance. Any coil with large self-inductance is called as inductor. The charge at any instant of time t we can write as like this. The Q is equal to Q0 cos omega t. Actually charge will oscillates in the circuit, means charge value increases decreases with the time, and the charge direction also changes. Once charge goes this side clockwise and other side next anti-clockwise, that's why the charge will oscillates with the time. Then the charge at any instant of time we can take as Q equal to Q0 cos omega t. While oscillating, its equation we can write as either sine or cos. But here we have to take the cos, because at time t equal to 0 we have to get the Q is Q0. The charge at any instant of time Q equal to we will get as Q0 if you write t equal to 0. If you write t equal to 0, you write here cos 0, you will get cos 0 value is 1, then we will get Q equal to Q0. Then we have to take this equation, Q is equal to Q0. Charge at any instant of time formula is Q equal to Q0 cos omega t, where omega is the angular frequency, t is the instant time at any instant of time, right? T is the time. And now here current in the circuit, current at any instant I want. Current at any instant of time t. The current is the minus of rate of flow of charge. Actually the charge is decreasing. At what rate the charge decreases in the capacitor, in the same rate the charge increases in the circuit through the inductor, right? Here minus indicates the decrease in charge on capacitor, minus d by dt of Q is the Q0 cos omega t. Okay, right. Here this we can write the differentiation, I is equal to, we will get as minus Q0 into d by dt of cos omega t, we write cos omega t. What is cos omega t? The cos omega t we write as, differentiation is minus sin omega t, will get, or otherwise you can take the current as positive also, you can take, there is no problem. In the circuit the current increases, current in the circuit is increases, we can take positive also, then there is no problem. Okay, the charge on capacitor decreases and the charge on current in the charge in circuit increases. Q0 d by dt of cos omega t. Cos omega t differentiation we know that minus omega sin omega t, right? This is the differentiation of cos omega t. Then current we will get as at any instant minus Q0 omega sin omega t, right? This is equation 2. Now I want the energy stored in capacitor. Energy stored in capacitor. Energy stored in capacitor. What is the formula for the energy stored in capacitor? That we will take as in the capacitor, in electric field it will be there, right? That is you write as Q square by 2C, energy stored in the capacitor at any instant of time, right? Then energy stored we write as Q square by 2C. Q is, we know that Q from equation 1, Q0 square q naught square cos square omega t. We can write one more step. Energy stored in capacitor at any instant. At any instant of time. At any instant of time. With the time, the energy stored changes. That's why we are taking the energy stored at any instant of time. T. What is that? That is a UE. Yes, it is the q square by 2c. But from equation 1, we know q is what? Q naught cos omega t. We write here q naught cos omega t whole square by 2c. Here we write as q naught square cos square omega t by 2c. Okay, even if you will, okay, then we can continue. And this is from equation 1. And the next, energy stored in the inductor. I want energy stored in inductor at any instant. At any instant. What is the energy stored in the inductor? That is the u suffix b we have to write. That is half L I square is the formula. Half L I is what? I is this one, right? We can take either minus or plus, whatever it may be. Square will be there, then there is no problem, right? Then what you will get? This is from equation 2. And we can simplify here. Energy stored in the inductor, half L into q naught square omega square sin square omega t. But we have one formula for the omega square. What is omega square? Omega square is 1 by LC of L q naught square. We derived the frequency in LC oscillation. Omega 1 by root LC. Omega square is 1 by LC sin square omega t. This LL will cancel and you will get q naught square sin square omega t by 2c we will get. This is we know from equation, since we write here, since omega is 1 by root LC. This we know already, right? And here we want the sum of energy stored. Okay, the sum of energy stored. Sum of energies in capacitor and inductor. Capacitor and inductor. Sum I want to calculate. What is the sum? U is equal, we write as UE plus UB, right? We have to add both of them. If we add UE, here we got q naught square by cos square omega t by 2c plus q naught square sin square omega t by 2c. Q naught square by 2c is common, then the remaining is cos square omega t plus sin square omega t. Its value is 1. Then finally we will get the q naught square by 2c. Then is the total energy stored. What you got here? The total energy stored we got is sum of energy stored in the capacitor and inductor. We got as sum of energy stored in the inductor and the capacitor we got as q naught square by 2c. This we can take as equation 3, right? Final equation is what? What you got the final equation? The final equation we write here, that we write as u is equal to sum of energy stored q naught square by 2c we got. This we can take as equation 3. From this we write the total sum of energy. Total energy is independent of time. Sum is independent of time. Sum of energies, this is u is the sum of energies. Sum of energies independent of time, right? Whatever we want, that we want to prove, that is we proved. we want to prove the sum of energy stored in the capacitor and inductor is inductor in LC oscillations or in the LC circuit is independent of time, that we have to prove. We proved here in the LC, in this circuit, the sum of energy stored in the inductor and capacitor is remains constant, because in this time term is cancelled, because cos square omega t plus sin square omega t is 1 we got. That's why there is no time term in the sum. That's why the total energy stored is independent of time. Thank you.